I'm Alan James. I've worked in DOW Automotive for 25 years and with the company for over 30. I'm the market manager for composites for North America. My focus is to see how do we grow composites in this marketplace, particularly in light of the fact of our lightweighting desire by the OEMs to improve fuel economy. The automotive market is always dynamic, which is why it's so exciting to be in. It's changing, and particularly these years we're seeing a drive to maintain comfort and improve creature comforts, electronics and other devices in the car. At the same time, there's a desire to make the cars lighter, mainly for CO2 emissions as well as meeting CAFE standards. One of the benefits of being able to use a plastic versus a steel is we can run thick and thin, and so simulation software becomes very important to know where can we thin parts, where can we thick parts, how do we ensure that we have the right flow, and at the end of the day, the right performance. When we look at lightweighting, there's a number of materials that are really designed around those applications. First of all, it would be remiss not to talk about adhesives, which are already being used to save fuel by allowing lightweight materials to be brought in. We have a Betamate technology for bonding, Beta Force technology, so two of our trade names that we use in this area. One of the products that we recently launched last year was Force 5300, which is a fast curing epoxy resin system that's designed to work with either glass or carbon fiber. And lastly, a product that we use is a Beta Foam, structural foam, which is used to reinforce, let's say, A pillars, B pillar areas. So instead of beefing up steel, you can keep to the same thickness of steel and use this to improve the crush and crash performance. When we think of why would you use a composite or a plastic in the marketplace, well, they can consolidate parts. When you get to consolidation of parts, you actually get into very complex designs and geometries, which is very beneficial for a plastic, because you can have a complex mold. You just have to worry about your die draws and slides and so on, but you can get to a very complex shape, so you can combine parts together. You can actually go thick and thin where it's applicable. You're able to add more functionality in a part, and if you can add more functionality, you have a better value proposition to the marketplace with using that part. And so you get into simulation of these parts and the flow of going into these parts, or if you're compression molding this part and you're making sure everything's die draw, you're going to do all that on a computer, make sure that it all fits before you ever go and make the first prototype. So this is where the advantage of it is to be able to make complex geometries as well as consolidate parts together, but now you have to get into simulation software in order to be able to minimize defects, minimize waste. So when we look at parts that are manufactured with plastics, and we also use simulation softwares to find out how to manufacture those with very complex, large geometry. How do you get the flow through these geometries? How do you do that? Bumper covers, fascias have been used for a long time in the industry, and Moldflow has been used to be able to go and gate those properly, understand where there could be defects, so you can either design the tools to minimize those defects. So a lot of the development is focused on compression molding, because some of these materials are not so fluid, and combining with let's say a lined fiber. So now how does this work in a compression molding situation? And so we use simulation software in order to develop all the gating locations. We were understanding exactly where there would be defects, and we built the part steel safe, so we only made one tool. There was no prototype tools. Everything was built off of simulation software. We're able to maybe replace 3 parts with one. In a load floor, there's multiple parts, for example, and if you can take 28 parts that are all welded together and bring them down to 1 or 2 that are joined together with an adhesive, we can save part count as well as can use to go to a lighter weight material. This fits in with the rest of Dow Chemical and Dow Automotive's whole desire to have sustainable technologies, where one is seeking to make products that make the world a better place to live in. The interior of a car has been driven for lightweighting technologies for some time. A lot of plastic components already there, and that's where when we think of Moldflow, where it's been used dramatically in the past. Now the question is, how do we get into primary structures? How do we get into semi-structural components, and how do we go and make those out of lightweighting technologies? And what are the tools that are going to enable us to do that, as well as the materials. So all this is being developed right now. It now becomes the domain of any material that can hit the performance and the other criteria of having a lighter weight, and if you can add other functionality together, you have this way to basically oust standard materials and replace them with composites. It's cost performance that sells a product. If you don't have the right cost and you have the right performance, you won't get on a car. So you have to manage that cost and performance to be able to get to the fuel economy.